Hello everyone and welcome to this video of presenting the Xolcano Technologies newest XT IoT V1, which is ESP8266 12F based Wi-Fi development board. The contents of the presentation would involve starting from the introduction, hardware overview, features and peripherals, sample function or test run, then the applications. The highly affordable and programmer-friendly XT IoT V1 development board would allow anyone to try out their ideas and implement prototype flawlessly. And also it helps users in easily connecting with any IoT platforms which are available online. And now we will look at the hardware overview and check out some of the peripherals on board. Starting with the power supply, the board would require a 12 volt 2 amps constant DC supply for the normal operation. Okay, now moving on to the main microcontroller, which is ESP8266 12F, which is also known as the Wi-Fi module. It possesses an 32-bit ultra-low power MCU clocked at 80 MHz speed and could also support till 160 MHz. It's been provided with an internal antenna also, you can see here. It has got some top features like Wi-Fi support at 2.4 GHz, and also it supports WPA, WPA2 security modes, and along with that it has got some smart configuration for iOS and Android devices. Apart from these, some of the other usual peripheral features are like HSPI, UART, I2C, PWM, GPIOs, etc. And one of the outstanding feature is like the standby mode, or also known as the sleep mode, in which it consumes the power which is like less than a milliwatt. Okay, now moving on to FTDI header, which is used for serial data communication at different voltage levels like 3.3 volts or 5 volts. Then we have I2C header, or also known as inter-integrated circuit communication, which is used for communicating with any other external devices, whether it may be storage devices or any other devices. The number of devices could range up from 0 to 128 maximum. And here we have got the programming switch, which is a two-state switch in which the user could choose the 2 states of operation. While programming, the user could keep it in programming mode. Once the code has been dumped on the board, it could slide it back to the running mode, that's when the code starts execution. Then here we have 3 power sources for external users like 5 volt, 3.3 volt and ground. And here we have reset button, which performs a full system reset upon clicking it. And next up is the run LED. This LED indicates the code being executed. Here we have the Bosch BMP180 sensor mounted on board. It also works on the I2C communication protocol, giving us the 3 parameters like barometric pressure, temperature and altitude. And here we have got the user button, whose operation will be specified by the user itself. And then we have got the OLED display, which also works on the I2C communication platform. Beneath the display, we have got the buzzer for sound indication. And here we have our power MOSFET output, which could handle the load up to 30 amps DC with voltage range of 0 to 20 volts. Then here we got 2 relays rated at 10 amps 240 volts on AC side and 12 volts on DC side. Both of these MOSFET and relays are being isolated through opto-isolation circuit. This is done for better galvanic isolation. So finally we have a 10K potentiometer as an onboard ADC input. Along with that we have got an ADC terminal for external ADC inputs. So this is all about the overview of the onboard peripherals. Alright, now let's test run the board and check out the functionality of the module. Here our IoT development board is being connected to the Blink platform. We will be controlling two relays and a buzzer. This is relay 1, relay 2 and the buzzer. These three are the real-time data such as temperature, barometric pressure and altitude, which are being fetched from Bosch BMP180 sensor, which is mounted on board. And these data are quite accurate, as you can see. In the same way, we can connect any kind of sensors in order to monitor, control and automate the application as per our requirements. So this is how the board performs. Alright, let's move on to the applications now. There are numerous amount of applications of this device. Some of the popular among them are home automation. Here we will be controlling the appliances, devices within the home or house, like fans, lights, gates, pet feeders, etc. It can also be interfaced with the Blink platform, which is being shown already in the previous video. It can also be used with Google Firebase, where the data can be stored in the Google Cloud platform, where it can be used for performing any analytics or accessing the data from anywhere around the world. Here we have the MathWorks ThinkSpeak, which gives us the insight of sensor data in terms of visual or graphical representation. The same goes with the Adafruit IO, except we can control the app here. This device supports IFTTT, where are simply known as if this then that. This is the platform which provides the kind of service where the user could program response to an event in the real time, just like getting lifetime notification on the device or on the mobile itself or so. It also supports Node-RED, which is a flow-based online tool where the hardware devices will be wired together programmatically in terms of nodes, which could be operated in many interesting ways. It also supports Arduino Cloud IoT platform and the voice assistant, which is one of the most popular platform where the voice control is used to control the applications. Google Assistant, Alexa, Siri are some of the best examples for this. Okay, this was all about the overview of the board. For more details, please visit our website at www.xolcano.com. If you want to purchase the module, the link is given in the description. Please subscribe, like and push the bell icon for further notifications.